title, data streaming engineer. This is kind of the new software developer. And frankly, software developer is just a fine term that I think we can all continue to use. But in a real sense, in this era that we're all in now, this massive paradigm shift, biggest one in a generation, it's going to last for at least a generation. In a real sense, we're all data streaming engineers now. Where we are right now is in a place where data streaming has become the new default. There's a new universal data substrate. It used to be whatever database you happened to be using. It was Postgres, it was MySQL, maybe some life choices had happened and it was Oracle. I don't know. But it was some database back 10, 15 years ago. Now that universal data substrate is increasingly just Kafka. On top of that, somewhere, you've got the code you actually write that does something useful for the people who use the code. Is it an internal tool? Is it something customer-facing? Code that actually does something to serve your customer is kind of what you should be doing. But in these times of transition where things are confusing, there's a lot of stuff in the middle, right? And it's not always clear. Between Kafka and me, I've got lots of choices of different pieces of infrastructure that I can use to solve different problems.
What does a product look like? I mean, on the screen, it looks something like this. And it has a bunch of information like the product name, the description, the image, the author, the price, the inventory. But essentially, that gets subdivided as well. That the product catalog information, the name, the image, the description, belongs in one boundary. The rating of that book belongs in another boundary. Essentially, all that's shared between these two things is a product ID. In both cases, we've got product ID and then a bunch of data. And then in another one, we've got same product ID and a bunch of other data. And then that price, product ID, and how did we come up with the price? Inventory and the product ID. Essentially, we end up with what nowadays is called microservices, where each microservice has its own data. But notice that it's not like we have a product microservice that owns everything about a product. Or we have a customer microservice that owns everything about a customer. When looking for boundaries, you'll usually find them going right down the middle of your entities, where different parts end up in different boundaries. So essentially, instead of thinking about this in terms of layers, what would happen if we took those vertical slices and said, you know what, those are our primary architectural concerns. If you're building a complex system, my guess is that sort of at an abstract level, you have this kind of set of layering in your mind. You have some kind of user interface invoking some kind of API, usually remote, which will invoke some kind of business logic, which will ultimately influence data that gets persisted in some database. Your thinking, and most of the thinking in the domain-driven design community, is that business logic layer right there is your domain model. I have news for you, it is not. Why? Because of that. It's not just one set of layers. Essentially, there are these slices, if you will, that kind of start at that domain level, going down in the sense of, well, I don't actually need the customer's first name and last name in the same table as their status information. Because really, those things vary independently of each other. From a single responsibility perspective, they have different reasons to change. So when we think about it, it's no longer just one system. Essentially, it's these sets of boundaries where not only going down, but also going up, we can subdivide them. So this idea of a bunch of the logic changing together between the customer and the product, but it requires time to sit down with your domain experts and kind of sift through what things really change together versus what things change separately. So saying, hey, we're going to take the customer first name, last name, phone number, that kind of stuff, we're going to put that in one domain. We're going to take the product names, descriptions, images, we're going to put that somewhere else. We're going to take customer statuses and product prices and the logic around discounting, we're going to put that somewhere else. This is the first act of finding your boundaries. So essentially, instead of that simple layered architecture that we saw before, we start subdividing that and saying, from a single responsibility perspective, they have different reasons to change. So when we think about it, it's no longer just one system. Essentially, it's these sets of boundaries where not only going down, but also going up, we can subdivide them.
So now we know why we started this journey. Let's take a look at what are microfrontends, and then we'll walk through some of those goals and how microfrontends can solve that. This is a quote from the microfrontends.org website. I think it describes nicely the concept behind microfrontends. The idea behind microfrontends is to think about a website or web app as a composition of features, which are owned by independent teams. Each team has a distinct area of business or mission it cares about and specializes in. A team is cross-functional and develops this feature end-to-end from database to user interface. So we already had these microservices on the back end. Now we want to extend it all the way to the front end as well. In the end, we want really create verticalized teams that can develop their features end-to-end. And in the end, we join all those microfrontends together and compose one unified application. That's the idea. So basically taking some of the concepts that work well on the back end and bring them to UI development as well.
So if we're looking back at our pet store, but a little bit better pet store thanks to Antonio. So we would have a product team which is in charge of this page, and it's the only one in charge of this page. And this team is going to use components provided by other teams, like the shopping cart menu provided by the checkout team, and the search bar, which is provided by the search team. And a very important idea behind microfrontend is that each team should be able to work with the framework they want, with the entire stack they want. So we can imagine here having the product team working in Angular and the search team working with Vue and the checkout team working with React, for example. So you still have small and specialized team, but now, and that's a big but, they are customer-focused team. So they only have one mission, and they don't have to care about what's happening in the rest of the application. Their only mission is to provide the better experience as possible in their part of the application.
As Ruth Milan famously said, system design is inherently about boundaries. Boundaries define how knowledge is flowing through a system and what kind of knowledge is shared between the different components. Now, going back to my previous question, two of the answers were data and information. So now we can compare them. Imagine sharing like petabytes of data through a contract-coupled interface. It's going to expose way less knowledge than sharing a few bytes of data through an implementation-coupled interfaces. That's why software design pumps knowledge through the system.
Nochmal auf unsere Definition. Also wir haben gesehen, dass dies hier eigentlich nicht groß taugt. Wir müssen die ersetzen. Ich habe hier natürlich auch eine mitgebracht als Alternative, als Ersatz. Microservices sind ein Architekturstil und eine Kultur. Über Kultur haben wir jetzt gar nicht gesprochen in diesem Video. Das ist nochmal ein anderes Thema, aber genauso wichtig. Und die Anwendung wird in eigenständige und isolierte Teilanwendungen gegliedert. Ja, und hier haben wir jetzt nicht mehr die Wiederverwendbarkeit und die Abhängigkeit der Services drin.
So when we build software, we design elements such as bounded context, services, components, modules, classes, or individual methods. And what's common to all of them is that they all have a boundary.
So the next question, I guess you're the right person for this one. How to define module boundaries in a complex domain?
So again, let's say that you have that complex domain. And by complex, what you mean here is, if I understand the question correctly, is complexity of the business domain, not of your solution. This talk was about complexity of your solution, not of the problem. When you have a complex business domain that you have to work with, you need a tool to understand what's going on there. It's more related to domain-driven design. The first domain-driven design book is called Tackling Complexity in the Heart of Software. So DDD provides a set of tools and practices for learning the business domain and for managing its complexity. Like bounded context that encapsulate different models. Each model is implemented to, each model is designed to address a specific problem, etc. That's the part of the problem domain. Now, the solution domain should manage that complexity as well, and this was the topic of this presentation. Again, knowledge sharing. Optimize how knowledge flows across the system. If you divide your system into modules in such a way that they exchange lots of knowledge, then probably that's not going to be good for your modularity. If you optimize that knowledge, if you divide it into components in such a way that minimizes the knowledge that is shared between them, then you will lower the cognitive load and you will make it more modular. So to sum it up, two parts: problem domain, you have domain-driven design to deal with the complexity of the problem domain, to understand the problem, and these tools to design modular systems. They defined what is a module. Here is a definition that comes from Glenford Meyer's book, Composite Structured Design, and in this book, Glenford says that a module is any collection of executable program statements meeting all of the following criteria, which is a fancy way of saying that a module is a piece of code that meets the following three criteria. First one is that piece of code should have a self-contained functionality. We should be able to define what is the functionality of that code, what it's supposed to do. Second, that functionality can be called from any other module. So that functionality should have a public interface so that we'll be able to execute from other parts of the system. And finally, the most important one here is that the implementation of that functionality has the potential to be independently compiled. And I highlighted that word potential here because it's super important. In modern literature, usually people say that component is physical boundary, which is compiled independently, but a module is a logical boundary, which is compiled with other modules. According to this definition, that's not the case. Whether we're looking at a physical boundary, which is compiled independently, or if we're looking at a logical boundary that can be compiled independently, we're still looking at modules. So where can we find those modules? Microservices, we have self-contained functionality of each microservice. Each one of them can expose that functionality to other parts of the system. It has a public interface, and of course, each one of them is compiled independently. That makes each microservice a module according to that definition from 70s.